Welcome to Fascinating Frontiers, episode 126. It's July 9th, 2026. Here's your space and science briefing. A Falcon 9 booster has now completed its 36th flight and landing, carrying 29 more Starlink satellites into orbit. The booster B1067 lifted off from Cape Canaveral Space Force Station at 0925 UTC, carrying the Starlink Group 10 to 42 mission. It touched down on the drone ship, a shortfall of Gravitas, after delivering its payload. This marks the first time any orbital-class booster has reached 36 flights and landings. The launch continues the steady cadence of Constellation replenishment flights. Next, teams will inspect the booster for any signs of wear before assigning it to a future mission. Now, shifting focus from sustained reuse on one vehicle to what happens when a star itself reaches the end of its life. Astronomers are examining how a planet remained intact after its star evolved into a white dwarf. The system shows the planet orbiting at a distance that allowed it to avoid engulfment during the star's red giant phase. Observations reveal unusual atmospheric or orbital properties that challenge standard models of post-main sequence planetary survival. Follow-up spectroscopy is planned to determine the planet's current composition and temperature. On a different note, a spacecraft is approaching the edge of our own star's influence. NASA's Pluto probe is approaching the region where the solar wind gives way to interstellar space. The spacecraft will become only the third human-made object to cross this boundary after Voyager 1 and 2. Instruments are already recording changes in particle populations and magnetic fields. Data from this crossing will refine understanding of the heliopause structure. Mission controllers expect several months of measurements before the craft moves deeper into interstellar space. From leaving the solar system, the story turns to a crew returning from its farthest crewed journey so far. The 4 Artemis II astronauts reunited with their spacecraft 3 months after completing the mission's record-setting lunar flyby. The capsule had traveled farther from Earth than any crewed vehicle in history. Engineers are now reviewing post-flight data and hardware performance. This reunion allows the crew to inspect systems firsthand before the next phase of vehicle processing. The experience feeds directly into preparations for the first crewed lunar landing. Next up, researchers have run scenarios testing how different numbers of astronauts affect mission success on the Moon. The study found that operational design choices, such as task scheduling and habitat layout, matter as much as psychological factors. Results suggest an optimal crew size balances workload distribution with available resources. NASA can apply these findings when finalizing Artemis base requirements. Additional simulations will test longer duration stays. From surface operations planning, attention moves to mapping the universe's largest structures. A 5-year survey has produced the largest catalog yet of massive galaxy clusters, some dating back nearly 8 billion years. The dataset maps the universe's largest structures in unprecedented detail. Hidden within the measurements is evidence that star formation rates across cosmic time differed from earlier predictions. Teams are now cross-checking the catalog against optical and X-ray observations. Future papers will examine how these clusters grew through mergers. Shifting to a nearby planet whose formation story remains unresolved, the 11 Jupiter-mass planet Beta Pictoris b orbits its 23 million-year-old star on a 23-year path. Direct imaging since 2008 has tracked its motion within the system's iconic dust disk. Current data cannot yet distinguish between formation by core accretion or disk instability. Additional observations with next-generation instruments aim to measure the planet's atmospheric composition and any remaining heat from formation. From formation puzzles, the view turns to a simple naked-eye alignment visible tonight. The planet Venus stands 1.1 degrees north of the bright star Regulus in LEO after sunset. Observers can watch the pair slowly descend together in the western sky. The conjunction offers a simple naked-eye alignment visible from most locations. No special equipment is required beyond clear western horizons. From easy sky watching, the focus moves to hidden effects on astronaut health. University of Central Florida researchers exposed liver cells to combined radiation and microgravity conditions. The resulting gene expression patterns match those seen in blood samples from actual astronauts. The work identifies specific pathways that could be targeted to protect crews on long-duration missions. Follow-up studies will test whether the same signatures appear after shorter flights. Next, infrasound and seismic networks turned an otherwise invisible daytime fireball over Alaska into a fully reconstructed event. A bright meteor crossed Alaska skies while the sun was still up, rendering optical cameras ineffective. Scientists instead used low-frequency sound waves and ground tremors recorded by earthquake stations to reconstruct the object's trajectory and breakup. The method captured the final seconds of atmospheric entry in detail. This approach could provide routine detection of daytime or cloudy sky events worldwide. Researchers are now refining algorithms to distinguish fireballs from other acoustic sources. If you could shrink Earth's atmosphere to the size of a football stadium, the thin shell where most meteors burn up would be only a few rows of seats thick. A daylight fireball releases energy equivalent to hundreds or thousands of tons of TNT, yet its optical flash can be lost against the sun. Instead, the event generates powerful pressure waves that propagate as infrasound, frequencies below 20 Hz, traveling thousands of kilometers with little attenuation. These waves reach ground stations hours later, while the same shock also couples into the solid Earth, registering as tiny seismic signals on earthquake sensors. One surprising number stands out. A single station can sometimes locate the source to within tens of kilometers using arrival time differences across a sparse network. The remaining mystery is why some fireballs produce unusually strong seismic coupling while others of similar size remain nearly silent on the ground, leaving researchers without a reliable way to predict which events will be easiest to study. From the oldest satellite still circling Earth, attention turns to a new national agency. Launched in 1958, the small sphere Vanguard 1 continues circling Earth more than 6 decades later. Its simple design and high orbit have allowed it to outlast every other early spacecraft. Radio tracking still confirms its position and slow orbital decay. No other artificial satellite from the first decade of spaceflight remains operational. On a different note, Singapore has formed a new space agency. The agency signed a cooperation agreement with Japan's space agency to support industry growth. Officials aim to develop local capabilities in satellite manufacturing and data services. The agreement includes technology exchanges and joint project planning. Early focus areas include Earth observation and communications applications. From agency building, the story moves to growing food on another world. Japanese researchers built a low-power system that extracts nitrogen directly from the atmosphere and converts it into plant-usable form. Tests in simulated lunar regolith successfully grew rice plants. An unexpected side effect improved nutrient uptake in the crops. The technology could support future lunar greenhouses while also offering applications for terrestrial farming in nutrient-poor soils. From lunar agriculture, the view shifts to the earliest building blocks of planets. A Southwest Research Institute study proposes that tiny moonlets once orbited early asteroids and concentrated millimeter-sized spherical particles. These grains later became the building blocks of the most common meteorite types. Computer models show how gravitational interactions could sort and preserve the material. Laboratory analysis of meteorites will test the predicted grain size distributions. From the earliest building blocks, data now reveal that the Milky Way's outer arms extend farther than mapped. Chandra X-ray Observatory data reveal spiral arm structures reaching beyond previous mapped limits. The extended arms contain hot gas and young stars at greater distances from the galactic center. Adjusting models of Milky Way structure will affect estimates of total stellar mass and rotation curve. Additional observations are scheduled to trace the arms in other wavelengths. Before we go, keep an eye on the next round of Artemis processing updates as the Orion capsule moves into its next phase of preparation. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NARA Network, links in the show notes. And before you go, this show is part of the NARA Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen, Environmental Intelligence, the Environment and Climate Policy Brief for Canada. Find every show free at naranetwork.com. Live dashboards, TSLA, SpaceX launches, the investing scoreboard are all at naranetwork.com/data. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly